Hello, welcome. We have a question here which is having square roots and an equation. So we can just say this is a spherical equation. In order to solve this, we are having the square root of 3x plus 1 minus the root of x plus 4 equals to 1. In order to solve this, we need to eliminate the square root. And in eliminating the square root, we have to look at the two sides of the equal sign, the left and the right. If I square here, I will be having double of the square root. So in order to have the square root on both sides, I am going to transpose the negative of this root to the right. And that will leave me the root of 3x plus 1 all equals to 1, then plus the root of x plus what? 4. In this case, I'm able to put the root sign on both sides of the equal sign. So what will I do? I am going to square the both sides of the equation. Squaring both sides simply means I'm having the root of 3x plus 1 all squared equals to 1 plus the root of x plus 4 all what? Squared. Now, in squaring, this is just a single term. That have a square, the square will cancel the square root, since the square root is a power of half. So I should be left with only 3x plus 1 in the case of the left equals to, if you recall, this is one term, the second term. So if I have a plus b all squared, this is the first term, which is the a, the whole of this is one term, which is the b. We only know that we square the first term twice their product. Simply put, 2 times a times b. That gives us 2ab. Then I square the last one as what? B squared. So in the same vein, I am squaring the first term, which will still give you 1. Then twice their product. That is 2 times 1 times the root of what? X plus 4. Then plus the square of the last term, which is the whole of this. Remember here, when we square the square root, it cancels. So we are left with only x plus 4. I guess we follow through how we manage to have 1, 2, 3 terms. This is 1, 2, 3 terms. All right, let's simplify the right further. And we are going to have 3x plus 1 equals to 1 plus 4, 5. Then plus x plus 2, the root of x plus what? 4. Remember, we still have the square root at one side. So let's eliminate this loose term here. Bring them all to the left. That means I still have 3x. The x is coming here as negative plus 1. 5 is coming as minus 5 equals to 2, the root of x plus what? 4. I think by computation, if you have 3x and you take away 1, you should be left with 2 of the x. If you have 1 minus 5, you need extra 4 numbers before you can be able to subtract 5 from 1. So we have negative 4 equals to 2, the root of x plus what? 4. It has what? A square root. So we need to cancel that square root also. Okay, in squaring that, I can see that there is a product of two numbers, the square root and the radical function here. So what should I do? Let me divide both sides by the 2. So if you divide by 2, you should be having 2x divided by 2, 4 divided by 2, 2 the root of x plus 4 divided by 2. By simplification, we should be having x minus 2 equals to the root of what? X plus 4. So now we need to get rid of that square root again. So we have the square both sides of the equal sign. That means your x minus 2 will be squared. The root of x plus 4 will also be squared. We are squaring because we want to get rid of this square root there. This is the square, the first, twice their product, that is 4x, square the last 4 equals to x plus what? 4. I guess we can now group our like terms here. We have x squared minus 4x. This is coming in as minus x. This is coming here as what? Plus 4 minus 4, leaving 0. So your x squared minus 5x equals 0. Don't forget 4 minus 4 will be 0. This is also quadratic, which has no constant term. So we can solve it in terms of factorization. So if I factorize x out, dividing this will give you only x, dividing this give you 5 equals to 0. So since both sides are multiplying to give us 0, it means that the first term is 0, I mean this one, or the x minus 5 is what? 0. So it implies that you are going to have x equals to 0, or x, when this transpose, equals to what? Positive 5. So these are the values that we are hoping to get for x. But we need to see whether these two values will satisfy the equation. If I put in 0 here, that means the root of 1, which is 1. 0 here means what? The root of what? 4, which is 2. So 1 minus 2 will give you negative 1, which is not 1. So it means 0 cannot be put in there, since we will be having the left different for the right. Then the 5 go in here, 15. 15 plus 1, 16. The root of 16 will be giving you what? 4. 5 here, making it 9. The root of 9 is 3. 4 minus 3 is 1. So we can say that, therefore, the value of x is only what? 5. Not the 0 and 5. The 0 will not work because it does not satisfy the equation. I believe you follow through. Like, share, comment, and subscribe.